Problem number 3. Let n denote the smallest positive integer that is divisible by both 4 and 9, and whose base 10 representation consists of only 4s and 9s, with at least one of each. What are the last 4 digits of n? Alright, well, okay. So, we can only have 4s and 9s in this number. Now, don't worry too much about this base 10 representation. If you understand, numbers in different bases, you might know base 2 or base, which is binary, or you might know hexadecimal. But you don't really have to worry about it if you don't understand what base 10 means. That's just our normal numbering system, okay, with place values, where the units digit, we have a units digit and we have a tens digit and then a hundreds digit. Okay, so don't worry too much about that. But essentially, we're looking for a number that consists only of 4s and 9s that is divisible by both 4 and 9. Alright, well, and it's handy to know the divisibility rules, especially for 4. And the divisibility rule for 4, so divisibility rule for 4 is that the last 2 digits, okay, last 2 digits must form a number that's divisible by 4. Okay, so we can just deal with the first 2 digits at first. Okay, if we're just going to look for numbers that are going to be divisible by 4. So let's take a look at that. We can only have 4s and 9s, so what are our possibilities? 44, 49, 94, and 99, right? That's the only possibilities. And of all of those, the only one that's divisible by 4 is 44. Okay? So that tells us that the last 2 digits are 4, 4. Alright? But we want the last 4 digits. So, now that we know that, we know the last 2 digits, let's see what else we can figure out. We gotta work with this divisibility by 9 issue. So what's the divisibility rule for 9? The divisibility rule for 9 is that, I'll just put for 9, let's copy this down, is that, what? The sum of the digits is divisible by 9. Alright, so our number is going to look like, well, let's define a couple of variables. So let's say n is the number of 4s in this number, and let's say m is the number of 9s. Okay, so when we sum up the digits, we're going to get something like 4n, 4 times the number of 4s, plus 9m, and that has to be a multiple of 9. Okay, so it's 9 times something. Okay, and if you think of it in terms of, we ought to be able to factor a 9 out of this expression, so we ought to be able to factor a 9 out of this. So if we do that, we get that, right? If we factor a 9 out of this, now I know there's not a factor of 9, but so we just have to divide by 9. But what that's telling us is that if there is obviously there has to be a whole number of 4s. Okay, you can't have 2.5 4s in your number. Okay, you have to have 1, or you have to have 2, or you have to have 3. You have to have an integer number of 4s in the number. So what that says, well, 4 is obviously not divisible by 9, so n must be divisible by 9. So that tells me that n is a multiple of 9. Okay, So the smallest multiple of 9, now we're told we have to have at least one 4, right? So the smallest multiple of 9 would be 9. Okay, 1 times 9. So what that's really telling us is that the smallest number of 4s that we can have in this number is 9. So we have to have 9 4s. And we have to have at least one 9 in there someplace. Now we've already got 2 4s because we've already found that the last 2 digits have to be 4. So we need 7 more 4s. And we need this to be the smallest positive integer. Okay, so if we're going to have one 9 and we're going to have 9 4s, because the smallest number is going to have the least number of place values. Okay, so we want the smallest number that has 9 4s and one 9, and the last 2 digits have to be 4 4. So we want to put the biggest number in the smallest place value. Okay. The last 2 digits have to be 4 4, so the smallest place value where we can put the 9 is there. And then the rest of them have to be 4s, okay? So we have to have a total of 9 4s. Alright, so we have 1, 2, 3, 4, 5, 6, 7, 8. Oh, we gotta have one more. So that's what our number looks like, right? We have 9 4s. Okay, so when you sum those up, you get a multiple of 9. And then a 1 9, and that's n, okay. But the question just asks for what the last 4 digits of n are. All right, so let's look at the last 4 digits of n, and it's 4944. All right, so there you go. There's the answer.